is does not susceptible. Otherwise, we say it's resistant to penicillin, which means 10 microgram of penicillin cannot do the treatment. So that's the Kirby-Bois test. Kirby-Bois test, we have to say, it is a semi-quantitative test. It's not really a quantitative test. We know the number, but we only know a range. Okay, but we have one thing I want to mention is that antibiotic test, you have to do is a specific bacteria for specific antibiotics. That pathogen coming from me and coming from you even react to the same antibiotics or different. That's why every patient, ideally you're using antibiotics, you need to do a special treatment, which is a pre-testing already. That's Kirby-Bois test. Okay, E-test, what this means. E-test is using a strip. This strip is manufactured already and containing antibiotics. So what they do is, we had our agar plates, let's say. This agar plates, I put a lot of bacteria, I put it in. Okay, it's not grown yet. Then I put a strip. That's called the E-test strip. And this strip has a concentration of certain antimicrobials, certain antibiotics, decreased by a certain factor. So, let's say start from here, 256. Then this is 128. Then this is 64. Then this is 32. Then this is 16. This is 8. This is 4. Now what we are looking for? You're going to looking for a number surrounded with transparent zone, but in the intersection for a turbidity area. That is a number, is your minimum inhibitory concentration number. What I'm talking about is MIC. Minimum inhibitory concentration. What we are looking is the intersection number. So you can see very strictly here is the intersection number. For example, this looks like 1.5. Okay, this one may be 1.5, 1.0. This guy is 0.75. That's the MIC number you should look for. Okay, that's E-test. But what is the more accuracy we should do? It's a quantitative test. A quantitative test is using tubes. So what they do, they're using a set of the tubes. Every tube, first of all, you put a bacterial solution mixed with antibiotics. And the antibiotics we do so-called two-fold C-area dilution, which means every concentration is divided by 2 compared to the previous one. Then we inoculate a bacteria and incubate at 35 degrees Celsius for 24 hours. But don't forget that there is 2 things we need to do. We need to have one thing, is no bacteria. It's called negative control. Because we want to make sure the bacteria medium is no bacteria there. We also need to control, which is all antibiotics. We need to make sure the antibiotics is not previously contaminated. Otherwise you get trouble. And then, after incubation, what you're looking for? The first tube showing completely transparent. Remember we talked about 3 markers for bacterial growth. Number 1, turbidity. Number 2, pellicus. Number 3, precipitation. Here, you're going to look in for turbidity. The first tube showing transparent. For example, for organism A is 0.12, therefore the MIC number is 0.12. In organism B, you see the first transparent tube is 1 microgram per ml, so that's MIC. And the last one, the first one, is 16 microgram per ml. Which one is better? Of course, the first one is better, because we want the number is the smaller the better. Remember, we don't want to be huge. And we also want them, the dose for the toxication dose should be the larger the better. What this means, even we using 16 microgram per ml, you still safe. You still cause any toxication reaction. So that's a very typical quantitative minimal inhibitory concentration test. Okay, almost done. We're gonna go to talk a little bit about antibacterial mechanism. What are the antibacterial mechanisms? Could inhibit cell wall synthesis, could inhibition protein synthesis, could inhibit nucleic acid synthesis, inhibit metabolic pathway, inhibit cell membrane integrity. Okay, which one is the most effective one? So everybody can think about that. Now obviously I put on the top. So inhibition of cell wall synthesis is the most effective. Why? Bacteria has cell wall. Does human being animal have cell wall? No. So what this means? The antibiotics is the targeting position for the cell wall is specific for bacteria. We don't have it. But how about protein? If it's inhibition protein synthesis, that is very obviously will cause severe side impacts. This is a reason some people using antibiotics will have yellow teeth, will have hearing loss, will have a yellow skin, will have a white blood cell number will be decreased, because the target of the antibiotics is not only for microorganisms that's coexisting in the human being or animals. So next week we're going to talk about these mechanisms. This is very important slides. We want to talk about this, maybe spending 10 minutes, 15 minutes. This is related to the principles of penicillin, which are the beta-lactam drugs, why it is so important. So we're going to go through this next week, Tuesday. Okay, so that is important slides, which tells you the mechanism behind it. And these slides could conclude lots of the knowledge we already talked about in this section in the previous 3 classes. So it's a good review slides also. Okay, so since it's snow, we'll let you go home a little early. I have 2 minutes earlier, so we'll end up today.